In this presentation, we will take a look at the future value of an annuity calculation, this time using months as the period as opposed to years as the periods. Here's going to be our information up top. We have the number of months, the number of periods being months, this time 3 periods. Once again, that being the big change here. Those 3 periods, not years, now in terms of months. The payment's going to be $10,000. The rate is going to be 12%. We can do this 3 ways. We can do it with the formula, with the use of tables, with the use of Excel. We're going to be concentrating on the tables and Excel. The table to the right, as we can see, has the rate up top, the periods to the left side. Neither the rate nor the periods show what periods we're talking about. Are we talking about the rate per year, per month? What's going to be the period? As long as we use the same period for both the periods column and the rate, then we'll be okay. So what we need to do then is change the rate over here from a yearly rate to a monthly rate. Note that within a book problem and in practice, you're generally not given oftentimes the monthly rate. And if it is given, it'll say per month, because if it doesn't say anything, it's assumed it will be the yearly rate, because that's normally the rate we just assume to have. So normally we'll have to take the yearly rate and say, okay, let's break it down into a monthly amount. To do that, we're going to take the 12%, divide it by 12. Notice that's an even calculation here to give us the 1%. And that's because, of course, if we're forced to use the tables, we need something that's even that will fit within the tables. We need a percentage that we have up top within the tables. In practice, we may have fractions, and we're okay with that. That means that book problems oftentimes will not have monthly periods, but only yearly periods. In practice, we may have to deal with, of course, monthly periods as well. So keep that in mind. We're at the 1% per month. And then we just choose the number of months, which in our case is going to be 3, that giving us the 3.0301. So we've got the payments, 10,000. We've got the amount, 3.0301, that giving us the future value of the annuity, 30,301. Then if we take a look at our functions within Excel, we can do this with a function within Excel. So here's going to be our argument. Here's the future value up top. We're going to put this into our argument area. So we have the rate in the top box, which is going to be B4. So B4 is here. We have the 12% in B4. Key point here, we're going to take that and divide it by 12. So we're going to take the rate, yearly rate, divide it by 12, giving us the monthly rate. In that case, it wouldn't matter in Excel if this was something other than 12%. If it was like, 5% divided by 12, we'd get some small number here. That's okay. Excel can deal with that. In our case, it's coming out to be 1%, 0.01. And then we got the number of periods, B2. That's in cell B2, 3 periods. Those periods representing months now. How do we know that? Because we're using a monthly rate. And therefore, the periods will be coinciding with that and be per month. There's the 3 on the right. Then the payment is in B3. So within B3, we have the 10,000, that being the payment. That's going to produce the answer of 30,301. It's a negative here. If we want to flip the sign, once we have generated the formula, we can put a negative in front of the function. That will flip the sign, in essence, taking that number and multiplying it times -1. So we have equals negative future value, and then we have B4. So B4 is going to be the B4, the rate, divided by 12, the number of periods, comma, and then B2, so within B2 we have the number of periods, which is going to be 3, and then comma, next to argument B3, which is the payment amount. This being an annuity, we have the payment, which is going to be the 10,000.